So for today's lesson, we're going to look at the Modeling Molecules Lab. The first thing you need to do is to figure out the electronegativity differences because that will help you determine what type of bond you have. So if we look at the example on here, we have an HO bond. So if we look at the electronegativity of oxygen, it is a 3.4 and hydrogen is 2.2. And you can find that on the back of your polar, nonpolar covalent bonds worksheet. So right here we have oxygen, right here we have hydrogen. So all we have to do is find those numbers on this chart right here. And then from there, we're going to just find the difference between them. So you always just put the higher number first. And so when we have 3.4 for oxygen, 2.2 for hydrogen, the difference is 1.2. So that means it's a polar covalent bond. So remember, in order for it to be a polar covalent bond, the difference has to be 0.4 and above. And so that makes sense that 1.2 would fit into that polar covalent. So the first thing you need to do is use this chart that you have and figure out what the bond differences are for each of these elements right here. Okay, so what you'll have to do on your own, like hydrogen and nitrogen. So find the difference between them. Just put the higher one first. You'll never have a negative difference, so always put the higher one first. So that's the first thing you need to do is fill out this side. So it's either going to be polar or nonpolar. Then, after you've completed this whole chart right here, and identified all the polar and nonpolar bonds based on their electronegativity difference. So we said if the difference is 0.4 and above, it's polar. If it's less than that, then it's nonpolar. After you're done with that, what you're going to do is you are going to start building these molecules. Because that will also help us determine if the molecule itself is polar or nonpolar, because you can have polar bonds within a molecule, but yet the molecule itself is nonpolar. And actually, there's a little chart right on the front that I'm sure most of you read anyway. But if all the bonds are nonpolar, then it's going to be a nonpolar molecule, which means it has no positive or negative end. But if there's one polar bond within this molecule, then it's going to be a polar molecule. And then, or if there's multiple ones, or if it's kind of hard to tell, then you have to look at overall, is the molecule polar or non, or does it have a positive and negative end? And if it does, then it's a polar. If it's not, then it's a nonpolar. But the first thing we need to do is build these molecules. So if we look at the first one, we'll walk through with this. So right now you should have your kits. So with all of your little parts and pieces in it. And we're going to build our first molecule on here, and we're going to sketch it the exact same way it actually looks on here. So it's not, you have to actually build it to see what the shape is. So the first one we're going to build is NH3. So nitrogen is going to be blue, okay? And then hydrogen is white. And then you'll notice that there are a variety of different bonds within here. So there's some purple ones, and there's some gray ones, and then there's some bendy ones. All right. So the bendy ones are what we're going to use when we need to have a double or triple bond. So then we need to use the bendy ones. So right now, it doesn't really matter which ones you want to pull out and use. So we'll just take these out. And so we're going to build it. And whenever you build these molecules, you need to make sure that all of the holes are completed. All of the holes are filled. So nitrogen, the blue, should have 3 holes in it. So 1, 2, 3. And then we're going to put 3 hydrogens. So there's 1 nitrogen and 3 hydrogens in NH3. And so as we kind of build this molecule here, we have NH3 right here. And so this is where we have 3 hydrogens. So the white represents hydrogen and the blue represents our nitrogen. So what I want to do is I want to sketch this molecule, and I want to give it this depth because it's not flat. Okay, so it's not completely flat. It has a little bit of an angle to it. And so when I sketch it, we're going to use our colors here. We're going to put nitrogen kind of on the top. So that's my nitrogen is the blue one. And then you can make the bonds whatever color you want. So I have one kind of going out here, one a little shorter here, and one in the back here. So this is kind of going to give it a little depth. because this isn't completely flat. This is not a flat molecule. So I have my hydrogens right there. I'm going to outline them just so we can see them a little bit better. So here's my hydrogens right here. And so this would be NH3. And what I want to do now is, so this kind of matches. So as you can see, oh, sorry, my finger's kind of in the way there. So there's NH3. So that's how it is kind of built. And now that we've made it, we can actually see that, it's not flat. So that's why we don't want to draw it like this, because this would make it look flat. So this kind of shows that angle that it's actually up a little bit. So we draw it like that. And then what I want to identify is the bond type of it. So is it polar or non-polar? So I'm going to go back to the front. And so you get a little bonus here. So we're going to look at the HN bond. And so looking at this, N is 3.0 right there. That's what it shows on here. And then we're going to subtract that from H, which is still 2.2. That hasn't changed. So our difference is 0.8, which means it's polar. So we've determined now that our HN bond is a polar bond. So it's sharing those electrons unequally. And so now looking at bond type, the bond type of it is polar. And there are 3 of them. All right, so there's 3 polar bonds. One right here, and one right there. So those are our 3 polar bonds. And then what we need to do is we need to identify the positive and the negative part of that polar bond, because when it's polar, it means that it has a positive part and a negative part. And so our positive is going to be the one with the lower electronegativity. And so since hydrogen is lower, so these are all my hydrogens, remember, because they are white. So hydrogen is going to have that partial positive charge to it. And then the nitrogen is going to be partially negative. All right. So we need to mark, so because there are polar bonds in here, we need to mark the positive and negative end. All right. And so we look and we have the negative is the nitrogen, because that one has the higher electronegativity. So right here's nitrogen. It has 3.0. And then we mark the one with the positive. The positive one is the one with the lower electronegativity, and this is 2.2. And right here it says if it's polar. If it was non-polar, we wouldn't mark anything. But because it is polar, we've identified it as polar, and that's just from the front, right here, polar, because it's 0.8 is the difference between it. So therefore, we have to identify the positive and negative. If the difference was 0 or 0.1 or 0.2 or 0.3, then it would be non-polar, and then we wouldn't have to mark anything. But because it is polar, we would write that in there. All right. So I'm going to walk you through the next one, and then the rest of them are on your own. So we have H2. And so we're going to grab one hydrogen and another hydrogen. And once again, it doesn't really matter what bond you want to pick. If you want to pick the little bendy ones, or if you want to pick the regular ones or the purple ones. I mean, it doesn't really matter. So let's pop this in here, pop that in there. And this is hydrogen. All right, this is H2. So I'm going to draw my, make my little sketch here, because white shows up really well on white paper. I'm also going to outline this. So I've got H here and H there, and then there's just one bond between it. So if you really want to write the H's in. And so the bond type. So because this is hydrogen and hydrogen, the electronegativity difference is 0. So therefore, it's going to be nonpolar. And the number of each, well, there's only one bond in here, so it'd just be 1. All right. And so that's all you have to write down. So what I want you to complete for today is these 2 columns right here. So I want you to actually make the different molecules, and then I want you to put in the bond types. And that's all based on their electronegativity differences. All right. And so when you're building these molecules, you need to make sure that all of the holes are filled. So the molecules in this kit are designed to make sure that they have the right amount of bonds to be stable. So for example, we had the white right here was hydrogen. Hydrogen only needs 1 bond. All right, so that's hydrogen. And then we have the halogens. So remember, the halogens are all group 17. So they need just 1 bond as well to be stable. So they're green. And then we have carbon, and carbon needs 4 bonds to be stable. So in order for your molecule to be correct, all 4 of these holes in carbon must be filled. Okay, so you can't just have a structure like this and have it be correct. Okay, that is not going to work. So because there's still 2 unfilled holes here. So that's where you can use make double bonds if you need to, or triple bonds even if you need to. You have to fill in all of the holes. So if you needed to make a double bond, all you would do is you would fit these bendy little ones in here, and then you just fold it over and voila. So that makes a double bond. Okay, so you can make double bonds and triple bonds as well if you need to. All right, you just need to make sure that all of the holes are filled in these molecules. So make sure when you build them that there's no open spaces. So use a double bond if you need to, or a triple bond if you need to, just to make it work. And then when you're sketching them, make sure you actually sketch what the molecule looks like. So, like I said, for this one, we don't want to sketch it flat because it actually does have a little bit of a tilt to it. Okay, it does have that angle there. This one, however, is just a straight line. Like there's no other way. I mean, there would really be no other way to draw this molecule. But the other ones, make sure you kind of take into account what the different shapes are. So when you're completing these, you're going to use as your key, red is going to be oxygen. The white, we've already identified as hydrogen. The blue is nitrogen. And then our greens are halogens. Yes, I expect you to know what the halogens are. And then the black is going to be the carbons. So if you don't have those particular colors, well, I just happen to have for you some crayons or colored pencils that you can use to make sure you color code your drawings correctly. Right. So that's what you need to work on and complete by the end of class.